All right. Good evening, good afternoon, good morning, wherever you are. It's time for another live stream. I hope you can hear me. I hope you can see me. Please give me an information on the chat. I hope I won't be lonely today. So one more minute for everybody that was late, and we are starting our 8th episode about AWS AppSync. Outside of this episode, we are just 2 episodes from the finishing line, but we will talk about it in a moment. All right, so let's start with the introduction. As usually we do, our main goal is to describe all those AWS messaging services. Today's topic is AWS AppSync. We already covered 7 of those services. 2 last from the final and finishing line. In the next week, we are talking about Pinpoint, and in the 2 weeks, we will talk about Kinesis video streams, in particular about signaling channels from the Kinesis video streams features. Today's topic is AppSync. So yeah, another interesting service, and some of you may be surprised because we are talking about messaging services and AppSync is rather about API integration because it's a GraphQL. We will talk about that in a moment. But the main point of today's topic is to discuss the subscriptions and WebSocket capabilities from the AWS AppSync. As usually, my purpose is to show you the deep dive into AWS messaging services and highlight proper use cases, differences between those services. I also challenge myself to teach you about things you didn't heard about or didn't know that existed in the first place regarding that particular saving. And we are doing the live stream format, so I count on your active participations here. So today's episode and today's theme is oriented around AWS AppSync, which will be fully related to GraphQL because it's a fully managed GraphQL service. So speaking about GraphQL, if you would like to power your applications with the right data and you would like to have clients to decide what kind of data they need, and you would like to fetch data from multiple data sources at a global scale, that's what GraphQL is. We'll talk about in a moment exactly what GraphQL is as a language, as a querying language, but on the AWS side, on the AppSync side, it's basically a fully managed version of service that is fully compatible with the Apollo server, and via dedicated Apollo SDK. For those of you who have heard about GraphQL, you are able to expose your GraphQL APIs via the Apollo server, which is available as a Node.js application, and you can have Apollo SDKs to create your clients and so on and so on. Additionally, AWS AppSync has the ability to generate clients for Android, iOS, React Native, and also web applications like React.js or Angular. It has native integration with the AWS Amplify framework, which is an interesting choice, an interesting framework for those of you who haven't heard about it. It's basically a client-side framework that allows you to write quickly and without a hassle applications for the AWS. AppSync as a service is ideal for mobile backends, microservice gateways, and offline applications. And on the left side, you can see the logo of that service. Okay, so As usually do, we've got three parts. One is about architecture, high-level overview, building blocks, integrations, and use cases. Then we talk about operations, high availability, scalability, pricing, and security. And last but not least, we talk about best practices, how to choose between services, and how to integrate with AWS ecosystem. One disclaimer, AWS AppSync is not an open source technology. It's not open sourced, so rest of the topics is often a speculation or deduction, or how the English people says, an educated guess. AWS documents most of the technical aspects, but if you will enter the gray area, I will tell you. So let's start with the high-level overview and the architecture. From the highest point of view, AppSync is basically a gateway that combines ability to access and intermediates between clients and the data stores. So for example, you can have enterprise applications, web application, mobile applications, all of those apps that can query your data via AppSync. If you would like to have ability to serve the data from various data sources, you need to write resolvers and rely on your GraphQL schema that allows you to define what kind of querying language you can apply to fetch your data. You can also fetch data from the other AWS services, as you can query over the PubSub or HTTP services. And last but not least, it fully integrates with the Amazon CloudWatch to have metrics, logs, and insights about this particular API. The main building block for AppSync is the GraphQL itself. And GraphQL is a data language that enables clients to fetch, change, and subscribe the data from the servers. In other words, it's a query language for your APIs. And the runtime, which is fulfilling those queries, is basically a server side of the GraphQL. And the runtime is often built in from the resolvers, which we will cover in a moment. GraphQL itself defines a schema. In order to query your API, you need to have a structure. That's why you need to define the schema. You are defining this by listing resources available in the API and specifying how many fields, what types of fields, what relations between those resources you have. And based on that schema, you can query, mutate, and subscribe on changes on those elements. Speaking about actions, query is basically written in a specific DSL that specifies which fields are needed and what arguments are passed, and provides ability to filter, paginate, and so on and so on. So the notion of querying is basically similar to the notion of queries in the SQL. However, if we will talk about second action, we will talk about mutation. If you would like to fetch the data, and just fetching the data is obviously a use case for GraphQL as well, but in many cases you need to modify the data as well. And you would like to have an ability to modify your data from the client side to the server side. By providing a mutation object, you will tell exactly which fields in which objects should be modified and how. And last but not least, you've got last action. Like queries, subscriptions enable you to fetch data. However, unlike the queries, subscriptions maintain an active connection with your GraphQL server. Most commonly, this will be a WebSocket. And this enables your server to push updates to the clients via subscriptions over time. And that's a great feature if you would like to build real-time APIs or establish the Delta syncs and offline connectivity. In many cases, GraphQLs are used exactly because of those capabilities. And subscription itself is a very interesting service for us, as we are talking about AWS Messaging Services, because it is a way to message to different parties via stateful channel, especially via WebSockets. And here is the example GraphQL. This is a schema for a to-do item. You've got the ID, a title of the to-do item, and the state completed or not. You can define the IDs and titles and completions as fields. You can also define the additional types. You can query those to-dos, and here is the difference between the entity and the query. In the query, you are specifying what you would like to fetch, and all those fields are listed here. Additionally, you are naming that query, so we are fetching here all to-dos without any filtering, any pagination. And by executing such query over the GraphQL server, you will receive all to-do items from the backend. If you would like to fetch just one to-do item, you can specify a query that fetches the particular item via ID equals 2. Thanks to that, we are basically doing a query with a where clause, so we are able to fetch and filter the data. If you would like to change the data and mutate it, you can specify a mutation object called a create to do. In this case, we are basically specifying what kind of fields and how they should be fulfilled, and we are defining this inside the create to do mutation object. And at the end, we are specifying what kind of fields should be returned after the completion of the mutation. So we are just returning the ID. Here is the way of defining the subscriptions. We can subscribe on the task completion here. So for a particular number, we can actually subscribe that this particular task, we should be notified when this particular task with this particular number will be completed, and the notification will arrive over the subscription. If this subscription will be fulfilled and the task will be completed, then we will receive the ID and the title of that task. From the high-level overview, GraphQL consists of those multiple functions, GraphQL Proxy. Those functions are called resolvers, and they are fetching the data from data sources. And also we can execute actions and operations on the GraphQL Proxy. That's a technical overview in comparison to the previous one that I'd explained you, which was the high-level API overview or entity overview. So GraphQL Proxy is basically a component that runs the GraphQL engine for the processing requests and maps them to the logical functions for data operations or triggers. The data resolution process performs batching, and this is data loader part, and this batching is executed on your data sources. This component also manages conflict detection and resolution strategies if those conflicts will arise. Additionally, you've got AWS AppSync client, and this is a location when the GraphQL operations are defined. So all those queries and mutations and subscription requests, all those things resides on the client side. And in the AWS AppSync scenario, there's a specific AWS AppSync client that stores those elements on the client side. Then the client performs the appropriate authorization and wrapping a request of the statements before the submitting to the GraphQL proxy. If the authorization will be succeeded, then you will be able to execute such operation on the GraphQL proxy. Responses are persistent in offline storage, and mutations are made in a write-through pattern. So basically, you are saving data to the data stores on the moment when you are proceeding the mutation. Speaking about high-level overview, all those queries, mutations, subscriptions, they are all called the operations. And action is basically a notification to connected subscriber in the result of a mutation. So clients become subscribers through a handshake process following a GraphQL subscription, and then they are receiving actions that are sent down to the line via subscription channels. I already mentioned this twice, an entity called resolver, and it is a function that converts the GraphQL payload to the underlying storage system protocol and executes the queries or mutations on the data store, if the caller obviously is authorized to invoke it. And resolvers are basically comprising the request and response mapping templates, which contains the transformation and the execution logic. Function itself is the single operation that can be used across the resolvers. So functions can be reused to perform redundant logic through a GraphQL proxy. So like function can be querying the MySQL or querying the MongoDB. Functions can be related with automation, with the transformation, validation, and so on and so on. All those functions can be pipelined into a resolver, and then either you can have a single function inside the resolver, or you can have a pipeline of functions inside the resolver itself. Functions are comprised of a request and response mapping template as well, a data source name, and a version. A data source is basically a persistent storage or trigger that will, along the credentials that are accessing the systems, will be executed on the storage side or on the trigger side. Your application state is managed by the system or trigger defined in the data source. So examples of data sources can be NoSQL databases, relational databases, AWS Lambda functions, any kind of HTTP API itself as well. And here is the overview of the data storages and resolvers. So if you will have a subscription on Create Message, for example, so we will receive those information over a secure WebSocket connection back to the clients, and the AWS AppSync manages those stateful connections and sends those data properly. From the other hand, if we will query and mutate the state, we will send this back to the AppSync data sources, and this will be done via resolver. So for each data source that we have on the right side, we need to write a resolver with the corresponding functions that will access the data. So there's also a concept called VTL, which is the acronym for Velocity Template Language. And this language is a DSL, a logical template language, that gives you the power to manipulate both the request and response is in the standard request response flow of the web application. So for example, you can have a response mapping template to maps the response from your data sources to a GraphQL response via VTL. And the same way you can have the request mapping template when you're mapping the payload from the AppSync directly to the AWS Lambda data source. And if you think about it, this is a way to integrate between two parties, between AWS AppSync and data source, without intermediaries in the form of, for example, additional lambdas that will execute a function or execute any other logic. Those VTL templates can be pretty heavy, and they are very interesting in the sense that you can have a lot of logic there. However, maintaining those resolvers and those request mapping templates and response mapping templates can be cumbersome, because VTL is not the most friendliest language available on the planet. So keep that in mind, and in some cases there will be a good way to handle those resolvers properly, will be to offload and delegate the responsibility to a proper AWS Lambda call. Additional building block that is not mentioned by me is the identity, because the GraphQL proxy performs also the authorization part. So identity is a representation of the caller, and based on that set of the credentials, it will be created if the GraphQL proxy will recognizes the caller. It also includes permissions to invoke resolvers, so you can have identity informations that are passed as a context to a resolver and the conflict handler to perform additional checks. Speaking about use cases, as I said, the most predominant use cases for the GraphQL and AWS AppSync is to have instant and real-time connectivity and communication. So any kind of chat applications, data broadcasting, even Internet of Things for the more beefier hardware and machines on the Internet of Things side will be appropriate. Additional use case is to have this service as a microservice gateway for your data layer. You can also have offline data sync, and speaking about microservice data layer, very good example will be to have a GraphQL as a polyglot persistence gateway. There is a great blog post about how to expose QLDB, Amazon QLDB, via AWS AppSync And this is available on the AWS blog. And this actually helps a lot when it comes to the integration with this interesting database service over a pretty standard API, and not limiting and not constraining the clients to actually fetch those particular elements that are designed to use as an API in the classic REST API way. So this is pretty interesting use case to analyze. Speaking about companies, and AWS claims that, for example, Ticketmaster is using this service. It is an e-commerce company that handles the event management and ticketing. Also, PureSec, Public Good, Cookpad, and Aldo. Most of those companies are actually software as a services that are also having mobile applications. As I said, the great example how to use GraphQL properly is to have a mobile backend, a mobile front end and mobile backend, and also have the unified API for your front end and mobile clients. So that's everything regarding the overview. And if you have any questions, feel free to drop them on the chat. But we are moving to a part 2, which is focused on the operational side. And as usually, we start with the high availability. And I'm already bored by that, because every single time that we cover a fully managed service, there is nothing really to talk about when it comes to high availability. In this particular case, it's exactly the same story, because it's a fully managed service, so it handles your high availability architecture with use of the multiple availability zones. However, if you need to have regional disaster recovery or regional failure protection, you need to take care about it yourself. When it comes to scalability, again, it scales automatically because it's a typical thing for a fully managed service. However, in terms of API, there is an interesting phenomenon and challenge that you would like to have a caching layer built into your API in order to not serve and not resolve some queries too frequently. And actually, AWS AppSync gives you that ability as well. You can have a fully managed caching layer that can be provisioned on demand with a flexible TTL management and also auto-scaling. So it's a pretty interesting service in a sense that you can have the ability to also have auto-scaled and fully managed caching layer for your API. Speaking about provisioning, it is exactly related with pricing. And as I said, it's basically a pay-as-you-go because it's a fully managed service. There's also a free tier available, but when it comes to pay-as-you-go, you are paying for various multiple factors. First things first, you are paying for query and data modification operations, so query, mutations, and subscriptions, and you are paying per million of those operations. Then you've got real-time updates, and you are paying per million about that as well. Then you are paying per minutes for active real-time connections, so all those subscriptions that are currently active, you are paying for each of those separately. You are paying per minute. Then if you set up caching, you are paying per hour per instance, because you need to provision your caching layer in the way that you are choosing the instance family and instance type and size. So you are paying per hour per instance depending on your needs and how you provision the caching layer. And last but not least, as usually with the AWS services, you are paying for the data transfer. And that's the thing that is often overlooked in the API case, especially in AWS AppSync, because many people think that if it's a fully managed service, you don't have to pay by the data transfer. And that's not true, because we all pay for the data transfer no matter what, especially if you are returning a lot of data, because the outgoing transfer from AWS is a paid transfer. The data ingress is in most cases free, and this is a case for AWS AppSync as well. Speaking about security, AWS AppSync supports full encryption in transit with the help of TTL and SSL. I didn't find any information about if the caching layer can be encrypted by the AWS KMS, so I assume that it's currently unsupported, which is a bummer, but probably will be fixed. Additionally, the API itself provides you various ways of authentication for the API layer. So for example, you can reuse the API keys, you can reuse the AWS IAM logic, you can integrate with the Amazon Cognito, or you can use any OpenID Connect compatible identity provider. So there's a few ways how to authenticate properly for the API and GraphQL API itself. And that's everything regarding the operations. It's not a lot, but as I said, it's a fully managed service, so there's a lot more to do on the development side than on the operations probably. Speaking about the part 3, let's talk about best practices and differences between various services. And as I said, if you will have any questions, feel free to drop them in the chat. I will answer them immediately. So let's move to the best practices. And before that, I will take a sip. So we will start best practices and discussion about the differences between services by discussing the difference between AWS AppSync and Amazon SNS. And on the first side, it looks like it's a totally different service, and the distinction between those two will be fairly easy to choose. And that's true. However, there are some shared use cases, especially related with the communication and the notification part. And I think that the best way to choose between Amazon SNS and AWS AppSync is to separate into two categories. If you need to have a reliable and highly scalable one unidirectional communication, I would go with Amazon SNS. And that's obviously often the case. However, if you would like to have a GraphQL service and bidirectional communication, request response pattern, then the AppSync is more recommended way, especially if you would like to have bidirectional channels like subscriptions. The next category in comparison is even simpler. AWS AppSync as a service does not provide you any queuing capabilities. So the difference between SQS and AppSync is pretty obvious. If you need queuing capabilities, you are going with the SQS. If you need GraphQL services and the API setup, and also messaging on back and forth when it comes to the real-time communication, then the AppSync is the better way to go. Difference between AWS AppSync and Amazon MQ is also pretty obvious. Amazon MQ is recommended when you need topics and subscription capabilities, and you have an existing message broker available and you would like to leverage that in the hybrid cloud manner. From the other hand, if you would like to use GraphQL again, and you would like to have ability to support multiple extensive client set, then the GraphQL is the way to go. And also Amazon MQ is rarely exposed publicly, which is the case for the AWS AppSync, and solution is pretty obvious. Again, another category, AWS AppSync versus Amazon Kinesis data streams. And here a difference is also pretty obvious. Kinesis data streams is a durable event log. It has buffering capabilities. It helps you with the consumers and shared throughput, and filtering is not needed, and so on and so on. For all those elements, KDS is the greatest possible thing. For other elements like GraphQL APIs, AWS AppSync is more recommended. Here's pretty interesting distinction, because AWS AppSync and Amazon EventBridge are totally different services, but they are sharing some common stuff, especially when it comes to the subscriptions. And I think that the EventBridge is recommended if you need to integrate with AWS services or third parties, or if you would like to have an event bus inside your application. From the other hand, if you need to communicate between mobile and backend and web and backend, then you need a real-time API, which can be handled by the AppSync. So I would go with those two in totally different use cases. The same goes with the AWS AppSync and MSK, so Managed Streaming for Kafka. If you have an existing Kafka cluster or you need to have a persistent and durable log of events, then MSK is the way to go. In other scenarios, probably you will know how to choose between AppSync and MSK. The difference between AWS AppSync and AWS IoT Message Broker is also pretty obvious. AWS AppSync is recommended if you are dealing with more sophisticated devices that have better capabilities and support for WebSocket protocol or have support for HTTP2, for example. From the other hand, Message Broker is recommended when you want to have the MQTT protocol. And if you would like to integrate with the AWS IoT suite and include features like rules on jobs. So speaking about those two use cases for Internet of Things, I think that AWS AppSync is recommended for the hardware and devices that are having better capabilities when it comes to the handling the better protocols and better hardware, more sophisticated devices, as I said. Because if you need to support WebSocket protocol, what would be the point to have the MQTT? Also, of course, if you have limited and constrained availability, constrained bandwidth, and so on, then MQTT is much more lighter. But distinction between those two is also pretty obvious and it should be easy to choose. So this service is actually interesting, but it's fairly easy to select when it comes to the between all those services that we already described in the past. What kind of integrations do we have when it comes to the AWS AppSync? So you can integrate with AWS Lambda, with the Amazon DynamoDB, with Amazon Elasticsearch Service, Amazon RDS, Amazon Cognito for authentication, AWS IAM for authentication, and to be honest, any other OpenID Connect provider also for authentication. So all those data stores can be handled automatically without any additional logic, and you can actually connect Amazon DynamoDB with the AppSync like you would connect with API Gateway. The same goes with Elasticsearch and RDS, and you can actually transform the GraphQL queries directly to SQL queries, to DynamoDB queries, or to queries to Elasticsearch. And integration with AWS Lambda gives you basically an unlimited way to connect multiple other services, because you can write your own customized data storage logic to access any kind of data stored anywhere else. And that's why the AppSync is a great way to be a gateway for your storage layer and microservice gateway for many other projects. And speaking about the integrations, here is a great example how you can use the AWS AppSync as a centralized point in your architecture. So your clients are first authenticating via Amazon Cognito, then after they are receiving the tokens after authentication, they can access the AppSync. And then AppSync is basically a gateway for all those services. It can integrate with HTTP webhooks, and it can have AWS Lambda resolvers. All those resolvers can fetch data from any kind of applications, even those that are hidden inside the VPC or over the different API gateways. You can also integrate AWS AppSync via HTTP webhooks with another AWS AppSync that connects directly to Amazon DynamoDB, as you can see on the slide. Another great example is how to leverage the Amazon Cognito, AWS AppSync, and Amazon Athena as a very simple way to handle your data lake querying layer. So you can actually have an ability to execute Amazon Athena queries on demand via AppSync. And there is a pretty easy to write resolver that can be transformed from any AppSync query to Amazon Athena Apache Presto-like query. And then you are basically ready to query your vast amount of data stored in Amazon S3, and The same goes with the integration between the results, because Amazon Athena can store the results inside the Amazon S3, which can notify the AWS Lambda and notify the AppSync for when the results are ready. And then when the results are ready, you can have and push them to the client via subscription. So here is a great example how to use the ease of use of AppSync with the data layer and data execution parts. Another great example is to show how you can integrate AWS AppSync with the data stores precisely for fetching the data directly for your clients. And here you can see that it can integrate directly with the DynamoDB Elasticsearch service, and all those data stores are actually populated by the different Lambda functions, and the client side is basically having a one entry point and one GraphQL server for accessing all the differentiated and distinguished data. So this is a very good example how you can leverage the power of querying language in order to support your needs and requirements regarding the veracity regarding the data. And that's everything what I prepared for today. So do you have any questions? I don't see any on the chat for now. Okay, so just to remind you, in the next week we will talk about Amazon Pinpoint, which is the very strange service in that list. So keep that in mind. And in 2 weeks we will talk about Kinesis video stream signaling channels, and that will be the last episode of the AWS Messaging Services. So if there are no questions on the chat, that's everything what I prepared for you today, and I hope that I will see all of you on the next episode on Tuesday and on the last one in 2 weeks as well. So last chance to give a question on the chat. Yeah, I don't see any. So thank you very much for your attention, and stay safe and stay calm. Goodbye. Cheers.